So this 6 millimeter what you drawn in the front view, we are now projected it down. Okay, and we need to resemble the question which says that after marking 10 you have to move in by 6 and close this C type on both the sides. So here parallel to this I will align the scale and darken it till 6 millimeter. Then I'll slide down, align with the bottom 6, and then we'll close this to get the C shape what is required. Okay, so if we can look at this drawing what I've drawn, intentionally I've drawn this kind of small error, that is you can see that on one side, the left side, the gap between the two lines are more and here the gap is less. So this much error is acceptable in engineering graphics because it happens that during projection your scale might not be parallel, so you may not get this equal. So that much error is acceptable in engineering graphics. So after you're done with this part 1, let us now try to draw the small rectangle 2. For that you need to identify where is this small shoulder coming out in the front view, that you need to identify. But the other dimension, that is this width, is same as this width, and that is 10 millimeter. So the next dimension is 10, but the first dimension you need to recognize from the front view itself. So in the front view, this small shoulder coming out is what we already marked 2 over here. So for that we need to project this end of the small shoulder from both the sides, and we need to darken that second part. So the second part is this rectangle, smaller one, which you can darken it on all the 4 sides. So here we can darken it on all the 4 sides. We'll close this rectangle now. So that is how the second surface is ready, that is this small rectangle what you can see on all the 4 sides. Okay, so that is how we are developing the object slowly. So first we have developed the circular surface, then we develop this C type, then the second shoulder. Now comes the third one. Third one is a rectangle of width 30. So the width is 30. The length is unknown, but you can make out from the front view. In the front view we have drawn a hidden line corresponding to this edge. So that edge will give you the front view. So if you try to compare, this edge is same as this hidden line what we have drawn. So if I can project this edge number 3 down, I can get the third surface which has a width of 30 mm. And if you carefully observe in this diagram, even this width is 30. If you keep your scale here, this comes out to be 30 only. So this gap is 30 itself right from the beginning, because if you look at the question, even this was 30 mm, this gap was also 30, and even this is 30. So 30 was uniformly maintained right from the beginning. So the length of edge number 3 is from here to here. So wherever this edge intersects the inclined surface, we need to project that down. On the other side also, if we extend this here, project this down. So after we projected edge number 3 down, the length of edge number 3 is from here to here. Observe thoroughly. And between these two projector, the length of 3 is from this edge what you already drawn till the new edge what is being produced. So from here, if you darken this up and down, if you can darken this up and down, and if I close this one, so that is how surface 3 is being developed. So surface 3 length is same as the hidden line length. Same way here also, from here, if I darken this part and the down one, and if I close this, so that is how surface 3 I am getting over here. So overall the object appears to be as one single plane, but there are many ups and downs. This portion is the semicircular portion, which is the topmost one. The next C type is the second lower, this is the third lower, and this is the fourth lower portion. So it is down, but it seems to be in a single surface. Now finally, after all the flat surface are done, we are left with the inclined surface, the U shape, what I am showing by shaded part. This portion we need to draw in the top view. So for that, line by line, if you observe, look at this inclined edge. So in the top view, if you observe from the top view, if I project this on the top, this inclined edge will be seen as a straight line, isn't it? So see, try to understand. So this inclined edge in the top view will be seen as a straight line, and that is apparent. Apparent means reduced length. The actual or true length is quite long, but the apparent length is reduced. Then you can see this edge of 50 mm width. So from here, what you can see is, you can see edge of 50 mm width, as you can see here. And then you can see the third edge, which is inside. So in other words, the outer edge of the inclined surface will be seen as a C type from the top view. So this outer edge will be seen as a C type from the top view. So let us try to do that. So if you look at this diagram, this is that inclined surface from here to here, and if I extend this down slowly, this missing part, first line, second and third, these three lines, if I connect this, I will get the inclined surface automatically in between. So what is the important conclusion we have learned from the last two questions is, in the top view, whenever you draw inclined surface, you always draw at the end, because you're going to get it automatically. If you start with the inclined surface in the exam, you will end with inclined surface only. So always try to draw the inclined surface at the end after you complete all the flat surface, because flat surface is easy to visualize and draw. Inclined surface is difficult to visualize and draw. So here, if I close these three sides, first double trace, here also double trace, and down also. Now if you observe thoroughly, this inclined surface will give me the same thing what I need from the question. So from the question, this C type, if you look at the C type from the top view, it will seem to be an inclined surface like a C type, that is over here. Same thing I need to replica on the other side because of symmetry. So because of symmetry, we need to show the replica. So on carefully analyzing the top view, the only thing what is left is, you can see at the bottom there is a semicircular edge. It's a cavity, and there is an edge going inside what you cannot see. So if you guess for a while, you will come to know that the first edge is here. Second edge, if you observe, look at this semicircle and this line, wherever they meet a corner, from this corner there is an edge going inside. So there are two edges in the top view what you cannot see. Okay, so this is something like a mountain. So assume that the object is like a mountain and there is a tunnel which is being cut. So from the top view, if you observe, you cannot see this tunnel, or you cannot see the edges of the tunnel going inside. And if you don't show that in the drawing, how will the reader come to know what is the depth of the tunnel? So in this top view what is being drawn, we have nowhere represented that there is a tunnel going inside and up to what depth. So from the front you can make out that this corner of the semicircle and this corner of the semicircle, if I project it down and if I draw hidden, it will show me that there is a semicircular tunnel which is going inside. So from here, if I extend this tunnel of radius 22 down, and on this side also if I extend radius 22 down, and if I draw hidden line from here, so let me draw a hidden line. So the hidden line should intersect the top and bottom point of the dark line because they are perpendicular. And second, from here So what does these two hidden lines represent? It represents that there is a semicircular cavity which is going below the object and you cannot see from the top view. So that is with this semicircular cavity we are talking about. So this is the end of the complete top view. So front and top view both are done. Now let us see the side view of it. Before we start with the side view, let us try to visualize the side view of this semi-cylinder what we started with. So in the side view, when you observe, this semicircular edge will be seen as a vertical line. So when I extend this here, so let me try to extend this. So this will be seen as a vertical line like this. Okay, so this semicircular edge in the side view will be seen as a vertical line. Then the bottom edge from here to here will be seen as a horizontal line. So from here parallel to this, the bottom edge will be seen as a horizontal line. Again, this semicircular edge will resemble a vertical line in the side view. So over here, if I extend this further, okay, now next and very important part, let us proceed with. Okay, so this boundary of the semicircle will be seen, but it is not throughout because there is a cutout in between. So you can see this boundary 15 mm, it is 15 written here. So up to 15 mm, you can see the boundary dark. So you need to visualize step by step. So after you reach this boundary, you can see up to boundary only, because in the side view, you can see everything what is above this. You cannot see what is going down. So you can see up to this surface only. So you can see the boundary as a straight line. Then this circular edge on both the sides will be seen as a vertical line, and then you have to close this one. So if I project these points down from here on both the sides, you can see that the surface goes down like this, and we need to close it. So that is how a C type is seen for the semicircular surface in the side view. So this vertical line, small line, is 8 mm deep. So that is how the side view of a cylinder is seen. So when we start with the side view, this portion, the top portion what I was talking about, was a C type. This we can draw at the end also. Let us start step by step. So the first nearest flat surface is this one, what can be seen. Second are these two flat surfaces in the side view what can be seen. Third is this 45 wala flat surface. So let us draw these three flat surfaces first of all, first, second and third. So we need to identify where are these flat surfaces in this front view first of all. So surface number 1, if you look in the front, it's a vertical line. So first of all I will erase the initially 1, 2, 3, otherwise it will create confusion. You need not erase the light lines, they need to be retained for construction purpose. Okay, so in the side view, this one in the front will be seen as a vertical line. So this is that vertical line, and that same vertical line is here also. So this is your surface number 1. Surface number 2 is this vertical edge. So if you try to compare this with the front view what is being drawn, so this height is your surface 2. Next comes surface 3. Surface 3 is the hidden edge what you can see here. It is this hidden edge. So this hidden line is surface number 3 from here to here. Now same thing what we'll be doing is we'll try to identify 1, 2 and 3 in the top view also, because once you come to know about front view and top view, and if you project them, the combination will give you the side view. So surface number 1, if you just extend this line, so this length from here to here, that is surface 1. Also in the top view, if you look at this diagram, surface 1 is seen as a line. In the top view, if you observe, 1 is seen as a line, and that line is here, the extreme one. Second one, if you try to observe, it is the C type what is drawn before, and second one is the small edge of 10 mm each. That will give you the second one. So in this diagram, that initial C type was here, and this line, this is our second part, and the next second part is here. So this is your 10 mm on both the sides, this length. So that length you need to project in the side view. Finally comes the third one. The third one is in between two. So in between two, this edge what is inside, this one, that is your edge number 3. Okay, so let us start one by one. First of all, we start with edge number 1. Okay, so if you look at this edge number 1, the height is 10. So that same height 10 is here. We need to project this 10 on in the side view. So we'll align the scale and we will extend this here. So remember, don't project everything and make a chessboard. What you do is that project one line, one point, darken that out, and then you think about the next part. So I will darken this 10 millimeter width. So see, this rectangle of length 50 and height 10 is ready. So this was the first rectangle. So if you view from the side, this is that first rectangle what you can see. Now this second rectangle, height you will come to know from front view, and width from the top view, that is 10 mm. So this second number height is already identified here. It is here. This is the second height. So let us project this second height on this side. Yeah, so it's done. Now the width of this second is 10. Okay, so if you look in the top view, try to identify where is this C type, this edge. So that edge is second is here, if you can make out. So you need to extend this till 45-degree line and then transfer up, and the combination will give you the second surface. So from here, if I extend this down light, and from here, these are the parallel surfaces. So this combination rectangle, that is height of second from the front view and width from the top view, will give us a second rectangle. So let us darken this. So darken this on both the sides. That is how surface number 2 is ready with us. So 1 is ready, 2 is ready. Now surface number 3 is the inner rectangle of height 45 and the width is 30. This width is same as 30 and height is 45. So height 45 in the front view is the height of this hidden line, and width 30 in the top view is this dark edge. This is 30. So see, 30 is already projected. Can you see that? It is the in-between gap within 2. But the height 45 is yet to be projected. So we need to project height 45. So for the top line is already done. From the bottom edge we need to extend this. And from the question itself we can make out that the third rectangle we need to close this to get a complete rectangle darkened in between 2. So here in between these 2 and at the bottom this one, and here we need to double trace. So that is how the third surface is also ready. Now once first, second and third is ready, we can easily get the inclined surface by closing the rectangle. By closing the rectangle, we can easily get the inclined surface. So here from the diagram, from the question, if you compare, from here only, if you compare this one, these 3 lines, first, second and third, we need to close. See this edge. This edge is nothing but the outer inclined surface. This is the second inclined edge. So this is the second inclined edge. And moreover, if you compare the front view, isn't this the inclined line? So if you extend both the inclined line, you will find that something is missing here. So this edge we need to close down on both the sides. Okay, so by closing it we get the inclined surface automatically. Now the part what is left is this the above cylinder, that is a C type. So this C type surface is being left out so that we can complete the side view. So to begin with, let us start one by one. So if you look at the if you look at the curved surface in the side view, it will be seen as a vertical line, correct? So in this question, the curved surface is this one. So this curved surface, when you look from the side, it is seen as a vertical line. So for that we need to close this edge, and it lies on the extreme side because there is no object beyond that. So we have closed this on both the sides. Okay, then as we discussed before, you can see the boundary of the cylinder, which is 15 mm wide. This is 15, and there is no need to measure 15 because in the top view you already drawn 15. So in the top view, if you look here, the cylinder is in the center, isn't it? And this dimension is 15, and one more 15 is from bottom. So if I project both this in the side view, I can easily get the cylinder. So from here, if I extend the ruler scale down, let me draw a light line first and second light line over here. Then parallel to this edge, if I extend a light line above and the second light line above, so the combination of both will give me that edge. So this is the boundary of the cylinder up to 15 mm, what can be seen dark. Okay, so once this 15 mm is drawn, you can see this circular edge as a straight line which is coming 8 mm down. Have we drawn this 8 mm somewhere in the front? Yes, it was the hidden line. So this hidden line was 8 mm. So from here, if I could extend or project this 8 mm, I can get these 3 lines darkened, which will give me the complete cylinder. So this gives me the complete cylinder, see, like this. So here the complete picture of the side view is ready. So if you compress the object like a sponge, so this object will look like this after you compress it. The only thing left in the side view is, see, there is a semicircular cavity which you cannot see from side, and the depth of the cavity is throughout. You cannot see the topmost boundary. So if you look at this diagram from the side view, when you observe, you cannot see this boundary of the semicircular cavity, and that is going throughout. So here this boundary needs to be projected. So let us project the boundary here. Okay, and that cavity is throughout, so double trace and draw neat hidden lines. So we need to double trace and draw neat hidden lines. So see, that is how I drawn neat hidden line. So this hidden line represents that there is a circular surface going inside. Let us talk about the axis now. How to draw the axis in the side view. So in the side view, what happens? Look carefully. So when you look in the side view from here, this edge at the bottom and the axis what is going inside, see this axis, both of them will overlap. Now the question is, if a dark line or an object line overlaps with an axis line, then what we need to draw? So the answer is, when you look in the side view, what comes first? Yes, object line comes first. So you need to draw object line here. Do not erase this and draw axis line, otherwise marks will be erased. So here, whenever object line overlaps with axis line, always draw the object line first. In other words, object line is more brighter because it is dark, and this is imaginary, that is medium dark. So when a dark line overlaps with medium dark, what you can see is dark one. So you should draw the dark line. So that is what we have to draw here. So here axis you need not draw because it overlaps. Okay. So as we discussed before, once the 3 views are ready, without dimensioning, drawing has no meaning. So we need to show 10 to 12 important dimensions, which comprises of length, width and height. Okay, now let us start with some important dimensions. So as we know that the important dimensions are one which covers length, width and height of the object. So the length of the object is given in the question as 90. Okay, and we can show length in multiple places. We can show in the front view here or with respect to top view also. So we cannot show 90 here, even though this is 90 from here to here, we cannot show here because it is very far from the actual object. So whenever you show dimension, it should be near to the object line. So here I can show 90 here. So let us erase a bit. From here we'll leave a gap of 2 millimeter and draw medium dark extension line. I hope all of you know by this time why we should leave a gap. So the gap is left so that you can understand the difference between object line and imaginary line. And from here medium dark line, and then neatly you have to show the arrow mark, the 3:1 ratio, 3 mm length, 1 millimeter width or height, and you should write 90 above the line. So the first dimension 90 is being shown, which is the length of the object. So take care about 9 how to write. Just refer the scale, and if you look at the ISO standards, how is 9 written like a G? Then 4, you need to take care of 4, 7, 9, very important numbers. Okay, so just look at the scale what you have. Now once length is over, height in the question is nowhere shown 85 directly. So height is being split into two parts. One is 70 and second is radius 15. So we need to add these two dimensions to show the height, which is that one is 70 till the center and 15 is the radius. So in this diagram 70 is the height, and height can be shown either in the front view or in the side view. So we can split like this. We can show 70 in the side view and we can show 15 radius in the front view. So we can do that. So from here you need to leave 2 millimeter gap and draw extension line like this, and from here at the bottom extension line, and leave a gap of around 10 to 12 mm, draw dimension line, show neat arrowheads that is being practiced before. Now the question is on which side will you write 70. Okay, so for that all of you should know this, कि whenever you write a number, assume that the left side is your hinge and slowly swivel. So when you swivel at an angle, 70 will still remain attached with the line, and when you make it vertical, 70 is written on this side. So the number along with the line slowly raises up, and that is how it is written above. So this is called above the line, and above the line. So same way when you write 70 here, 70 should be written like this. But height is not only 70, we need to show radius 15 also. So the reader will read 70 from here, project this here, and from here you need to show one arrowhead, and in the question you have to copy from the question. Don't try to write diameter. In the question it is mentioned R15. So you have to just pick up from the question and place it here. So above the line, you should write this as capital R and 15. You have to see to it that the font size should remain uniform throughout. Okay, uniformity and consistency is more important in drawing. So after length and height, now comes the width. So width of the object, if you want to show 10 to 12 dimension, what you do is that you pick up multiple dimensions together. For example, you pick up 10, 30 and 50 together and show them at a time. So always show smaller dimensions first, followed by larger one. So if you look at this diagram, in the top view, this dimension is 10, what is given in the question, and this is 30. So here we can show 10. So see, now 10 don't show from here, because if you show like this, it is not very clear कि 10 is from where to where. So 10 actually is from here to here. But if you show extension line from here, it is not clear. So what you do is that from here, leave 2 millimeter gap and then show extension from inside. Similarly for 30, show extension from inside and then a common line, and then you should write this as 10 and as well as 30. So write 10 above the line and write 30 on this side. So 10 and 30 can be shown together. We can show 50 later on here also, or you can show in the side view. So already top view has 3 dimension. So let us show 50 in the side view. So 50 can be shown here. So don't forget to leave a gap of 2 millimeter, and you have to show medium dark extension line over the projection line what you have drawn before. You have to show the projection line what is drawn before, and this width is 50 millimeter, so we are showing 50 over here. So you can see that length, width and height are shown, and if you count the dimensions 1 2 3 4 5, only 6 dimensions are there. We need to show some more. So in the front view the number of dimensions are least, only 1. We need to show few more, so we can show radius 22. So how to show radius 22, let us see. So dimension should never be shown inside the object. What I mean to say is, don't write R22 inside the view. Then what one can do is, you can either extend it too long or you can extend it behind also, like this. So extending behind is a good technique. So from here you can draw a horizontal line and you can write R22. So R22 can be written here. So that is how we have written radius. See, it's written here also and here also. The difference is, here is written outside, here it is on the inner side. So both are acceptable. Okay. So apart from this, we need to show 3 more dimensions. We can show this 40 in the front view, or we can show this 10, we can show this 20, 15. There are many options. So in the side view, see, this dimension is 15 and 20. Okay. So in the side view we can show this as 15 and this as 20. So from here we can show multiple dimensions. So here this dimension is 15 and this dimension is 20. So after everything is done, 1 2 3 4 5 6 7 8 9, one more we need to show so as to complete. So in the front view what one can do is, we can show this 10 what is shown in the front view. Along with that, this 40 can also be shown. So this dimension is 10 what is given in the question, and the behind dimension is 40. So this 10 can be shown here. Always write above the line 10 and 40 shown here. Okay, so these are the complete 3 views what is required for orthographic projections. Now to make this very clear, if I draw the intermediate XY line and if you try to visualize our basic concepts of graphics, so this view is called as the front view. You need not write in the exam, just for your reference. This view is called as the top view, and this is our left hand side view on the right. Okay, the red line is our XY line, we know that. Okay, so we also know that front view is drawn on the vertical plane, so this is our vertical plane. You should know about that. Top view is drawn on the horizontal plane, so this is the horizontal plane, and left hand side view is drawn on the right profile plane, so this is our RPP. If you close these planes, for example this is HP, so if you close HP and if you close right profile plane, you are going to get 3-sided planes, and when you open them up, that is how drawing is drawn. So if you hold this front view in your hand and if you take a turn, you will get left hand side view. So just turn on this side. Okay, so this is the front view, and if you just turn on this side, you will get the side view. This is the front view. If you just make it to stand, you get the top view. Okay, the front view is here. If you want to see the top view, just make this to stand, so the top view can be seen here, and this is your side view on the other side.